Basic concept is the solution to a system of linear equations is an ordered triple x, y, z. To solve a system of linear equations in 3 variables, we need at least 3 equations. In fact, your rule of thumb is that for a system of n variables, you need at least n equations to solve all variables. Now realize any system of equations, you can have, no matter how many linear equations are, you can have 0, 1, or infinitely many solutions. Solving with the elimination or substitution methods. We'll actually see an example where I'll apply both. But we went over these in section 6.1 and 6.2. To solve using one of these methods, we're first going to sit there and eliminate one variable from 2 of the equations, say x. We will use either the substitution or elimination method to get rid of one of the variables from 2 equations. If we do this properly, we'll now have 2 equations with just 2 variables. Say if we got rid of the x, we'll have 2 equations, one with an x and one with a y and z, and the other one with a y and z. We now, if having 2 equations with 2 variables, can go back and apply the substitution or elimination method again and solve for both y and z. And once we know y and z, we can plug back in and get our third one, x, and get a solution in the form x, y, z. Let's look at an example. Solve the following system. I have x plus y plus z equals 6. 2x plus y minus z is 1. 3x plus 2y plus z is 10. I want to eliminate one of the variables. I'm going to choose x to get rid of. I'm going to use the substitution method. I'm going to pick the top equation, and I know that x is negative y minus z plus 6. If I take the second equation, 2x plus y minus z is 1, substitute in for x, this becomes x is negative y minus z plus 6. I now distribute, I get negative 2y minus 2z plus 12, plus y minus z is 1. And when you combine like terms, you get negative y minus 3z is negative 11. You can now do the same thing with the third equation. 3x plus 2y plus z is 10. Substitute in for x, you get 3 times the quantity, negative y minus z plus 6, plus 2y plus z is 10. You get negative 3y minus 3z plus 18, plus 2y plus z is 10. That reduces to negative y minus 2z is negative 8. We now have a system of 2 equations with 2 variables. We can apply either the substitution or elimination method. Let's use the elimination method. Here your LCM is 6. Here your least common multiple is 1. They're both negatives, so I need to change one. I'm going to leave the top one the same. I'm going to change the bottom equation by multiplying everything by negative 1. You get y plus 2z is 8. So you have negative y minus 3z is negative 11. Y plus 2z is 8. We add them together, you get negative z is negative 3, so z is 3. Plug back in, and y plus 2z is 8, so y is 2. Again, we're not finished because we have 3 variables, so we go back to our original equation. X is negative y minus z plus 6, so negative 2 minus 3 plus 6 is 1. So the solution for x is 1, and the solution for everything is 1, 2, 3. And again, if we plug in 1, 2, 3 here, 1 plus 2 plus 3 is 6. 2 times 1 is 2, plus 2 is 4, minus 3 is 1. 3 times 1 is 3, plus 4 plus 3 is 10. These all work.